We're now in section 5 of topic 5, where we're going to be naming and writing formulas for covalent compounds. For covalent compounds, particularly binary covalent compounds, remember binary meaning there's only two elements. We're going to use the Greek prefixes that we saw at the end of the section for ionic. So as a review, the prefixes are right here, and they're going to indicate quantity. Since covalent compounds are held together by shared electrons and not transferred, there's no cations or anions involved. So this time, it's going to be important that we indicate the quantity of atoms in a particular name. So let's take a look at how we'll do that. When you're naming the first element, name it as is. So whatever the element is based on the periodic table, we name it just like that. But what we'll do is we'll add a prefix indicating how many of that element there is. If there's only one atom of the first element, you do not need to include the prefix mono. Just leave it without a prefix. Then move on to naming the second element, but change the ending to IDE, just like we did before with ionic. The only difference is we need to add a prefix for the second element as well to indicate the quantity. This time, if there's one, we'll add mono. So let's take a look at some examples just so you can see how this plays out. N2P5. I notice this is a covalent compound because the two elements are nonmetals. So I'm going to use my covalent naming rules. First step, name the first element as it is. The element N is nitrogen. But what I'm going to do is I'm going to add on to that a prefix to indicate how many nitrogens there are. Since there's two, I'm going to make this dinitrogen, and that's all one word. Next, I'm going to name the second element, but I'm going to change the ending to IDE. So P is phosphorus. That actually gets, that gets changed to phosphide. That makes a lot more sense than phosphoride. But we have to put a prefix in front of phosphide to indicate the quantity. There are 5, and so that would be the prefix penta. So dinitrogen pentaphosphide would be the name. Let's look at the next one, CS. The first element is carbon, and so I'm going to do that up here. So we're going to write it as is. Now there's only one carbon, but since carbon's the first element, we do not need to put mono. The second element is sulfur. We're going to change that to sulfide, but there's one sulfur, so I need to put mono. So it becomes monosulfide. So the name of the compound is carbon monosulfide. Finally, SO3. The first element is sulfur, and there's only one of them, so we just write sulfur, no mono. The second element is oxygen. We change it to oxide, but we include a prefix to indicate how many, which is trioxide. Now some of you might be thinking, wait, I thought SO3 was sulfite. Be careful. Sulfite is SO3 with a -2 charge. Since this one doesn't have a charge, it's neutral, and we call it sulfur trioxide. Go ahead and try example 8 on your own here. You can probably figure out what these are based on what we just did on the previous slide. All right, let's go ahead and take a look. Sulfur tetrafluoride would be SF4. Tetraphosphorus, so phosphorus has 4. Decasulfide, sulfur has 10. And then tribromine, bromine has 3. Notice it's heptoxide, so it's oxygen with 7. So we don't say heptaoxide, we just say heptoxide. A lot of times that happens. So when you get two vowels next to each other, often we'll drop the vowel on the prefix. Now, the fun thing about covalent compounds is there's a lot of exceptions. So let's take a look at some of those exceptions. First of all, compounds that contain tin and lead. You will see commonly these compounds can actually be named using either ionic, or we can see them using covalent naming. If you name them ionically, you would name it with the metal, followed by the Roman numeral with the charge, and then chloride, such as tin 4-chloride or lead 4-chloride. But They also could be named covalently, such as tin tetrachloride or lead tetrachloride. Both are actually acceptable in common literature, but we are going to be consistent. In this class, we are going to use the ionic naming rules because tin and lead are metals or cations. So that's what we'll do in this class. Probably one of the most notable exceptions are carbon-based compounds. Carbon-based compounds are organic compounds, and as such, organic chemistry actually has its own set of nomenclature. So let's take a look at some of the examples. CH4. Notice we don't name that carbon tetrahydride, we name it methane. C2H6 would be ethane, C3H8 would be propane, and so on and so forth. We see they have different naming rules. You need to make sure you know these names. Know these compounds and their respective names. Now, just to make you understand where these formulas are coming from, we're essentially just increasing the carbon chain. So, for example, CH4 is just one carbon with 4 hydrogens around it. If you increase the number of carbons by 1, making it now 2 carbons, you'll notice there's got to be 6 hydrogens attached to it. If you have 3 carbons, you would have 1, 2, 3, 4, 5, 6, 7, 8 hydrogens attached, and so on and so forth. That's where we're getting these. You can think of it as this. Whatever the subscript is for a carbon, that's going to be 2 times that number plus 2. So that's how we get these right here. But you need to make sure you know these names, particularly methane, because that'll pop up a lot in this course. All right. Hydrogen-containing compounds also have special names, such as diborane, silane, or silane, and so on. You only need to know these two. These are the only two that I need you to know. NH3, we will not call that nitrogen trihydride. It has the name ammonia. Don't get that confused with NH4+, which is ammonium. They are 2 different things. And H2O, I'm really hoping I don't need to help you with that and remind you that that's water, not dihydrogen monoxide. Although you never know, so I gotta make sure I go through that. All right, continuing on with the exceptions, when you have a hydrogen compound such as this, HCl, HBr, H2S, but it's in the gas form, you may be tempted to name these as they are acids, but as we're going to see in the next video, acids need to be aqueous. So what happens when it's not aqueous but they're in gas form? We're essentially going to name these as if they were ionic compounds. So for example, HCl will be hydrogen chloride. HBr will be hydrogen bromide. H2S, even though it has 2, we're still going to just call it hydrogen sulfide. So that's the exception for there. All right, we've covered ionic, we've covered covalent. The next video to end this topic will be acids.